Hello again, I'm Mr. Luis, and today we'll be exploring correlations, one of the key statistical methods used in psychological research. Unlike experiments, which manipulate variables, correlations help us understand the relationship between two covariables. In this video, we'll define what a correlation is, explore its strengths and weaknesses, and look at how correlations are used to measure relationships in research. What is a correlation? A correlation is a research method that looks for a relationship between two measured variables. In a correlation, a change in one variable is related to a change in the other. However, it's important to note that a correlation does not necessarily imply causation. It simply shows that two variables are related in some way. For example, a psychologist might want to investigate whether there is a correlation between the amount of sleep someone gets and their level of anxiety. If a positive correlation is found, it might suggest that more sleep is related to less anxiety or vice versa. Key terms to know: covariables, the two variables that are measured and compared in a correlation. Correlation, the relationship between two variables where a change in one is related to a change in the other. There are two main types of correlations, positive and negative. In a positive correlation, as one variable increases, so does the other. For example, there might be a positive correlation between hours of study and test scores. The more hours a student spends studying, the higher their test score is likely to be. In a negative correlation, as one variable increases, the other decreases. For example, there could be a negative correlation between screen time and quality of sleep. The more time a person spends looking at screens before bed, the worse their sleep might be. Strengths and weaknesses of correlations. Strengths. One of the biggest strengths of correlations is their ability to be used in ethical and practical situations. In many cases, it simply isn't feasible or ethical to manipulate certain variables in an experiment. For example, it would be unethical to run an experiment on long-term exposure to violence and its effects on behavior. However, correlations provide an alternative, allowing researchers to study the relationship between variables without manipulation. This makes it possible to examine things like the relationship between television exposure and aggressive behavior, without putting participants at risk. Another strength of correlations is that they help identify relationships between two variables. By establishing a link between two covariables, correlations provide valuable insights into how they are connected. While a correlation study doesn't explain the cause of the relationship, it sets the stage for further research, often guiding the design of experiments that can explore the variables in more depth. Weaknesses. Despite their strengths, correlations have their limitations, particularly when it comes to establishing causality. A key weakness is that correlation does not imply causation. Just because two variables are related doesn't mean that one causes the other. For example, a positive correlation between ice cream consumption and murder rates might suggest they are linked, but this doesn't mean eating ice cream causes crime. In reality, a third variable, like hot weather, might influence both. People tend to eat more ice cream in the summer, and warmer temperatures could lead to more aggressive behavior, creating the appearance of a correlation when in fact it's just a coincidental relationship. Another issue with correlations is the potential for confounding variables. These are third factors that might influence both of the covariables. For instance, in a study examining the relationship between sleeping hours and test scores, a confounding variable might be the overall health of the participants. Healthier individuals may naturally get better sleep, and their improved health could also lead to better test performance, which could distort the correlation. To understand a correlation fully, researchers often use scatter graphs to visually represent the relationship between the two variables. This helps in identifying whether the relationship is strong or weak, and if it's positive or negative. For example, let's consider a positive correlation. As physical activity increases, overall well-being may improve as well. This might suggest that more exercise is related to better health. However, it doesn't tell us that exercise causes improved well-being, it only shows the relationship. Correlational hypotheses. When researchers conduct a correlation study, they begin by formulating a hypothesis about the relationship between the two covariables. This hypothesis needs to be operationalized, meaning the variables should be clearly defined and measurable. Without clear definitions, it's impossible to accurately measure or assess the relationship between the variables. For example, a non-directional hypothesis might state there will be a correlation between the amount of sleep and levels of anxiety. This hypothesis suggests that there is a relationship between sleep and anxiety, but it doesn't specify whether more sleep results in more or less anxiety. A directional hypothesis, on the other hand, is more specific. It predicts the direction of the relationship, like there will be a positive correlation between the amount of sleep and lower levels of anxiety. In this case, the researcher is suggesting that more sleep will lead to less anxiety. It's crucial that the variables in these hypotheses are measurable. For instance, hours of sleep can be easily measured, and anxiety levels might be measured using self-reported scores or a standard anxiety scale. Applying knowledge of correlations to novel research. Now let's look at how you might apply this knowledge of correlations when designing a new study. First, you must decide which two variables you will measure. For example, you might investigate the relationship between hours spent watching TV and levels of happiness. Next, you'll need to think about how you will measure those variables. For the TV watching variable, you could use a survey asking participants how many hours they watch TV per week. For happiness, you might use a test or behavioral observation to assess how content the participants are. You should also consider the type of correlation you expect. Will it be a positive correlation, where both variables increase together, or a negative correlation, where one variable increases while the other decreases? Lastly, you must decide whether a correlation study is the best approach, or if another research method, like an experiment, would be more appropriate. In an experiment, the researcher manipulates the independent variable IV to see if it causes a change in the dependent variable dV. In a correlation study, however, you simply measure the variables without manipulating them. Real-world example, Professor Chow's study on phobias. Let's look at a real-world example of a correlation study. Professor Chow is studying the relationship between the duration of a phobia and its severity. She hypothesizes that there is a positive correlation. The longer a person has a phobia, the more severe it becomes. To test this, she asks participants to record how many years they've had their phobia and rate its severity on a standardized scale. This study is a correlation study because Professor Chow is not manipulating the duration or severity of the phobia. Instead, she's simply measuring these variables to look for a relationship between them. In this case, the correlation between the duration and severity of the phobia could help us understand how these two factors relate to each other without establishing cause and effect. Conclusion. Correlations are a useful method for exploring relationships between two variables, particularly when experiments are not possible or ethical. However, while they help us identify patterns, they cannot tell us if one variable causes the other. Always remember, correlation does not equal causation. Thank you for watching. I hope this helps you understand correlations better. Stay tuned for more psychology topics, and don't forget to like and subscribe for more educational content.